Alright, so this video is going to show you how to find the slope of a curve at a given point. So you start with a function, and you have to have a point on that function. Alright, so let's see. I've got the graph of a function here, the function we're going to use. So this is the graph of y equals x squared minus 4x. Okay, and we would like to find the slope at the point, let's go 3 minus 3. So it has to be a point on the curve, and we can see that 3 minus 3 is this point right here. We would like to find the slope of that slope of the curve at that point, which, if you remember, means we're going to be trying to find the slope of this line that is just tangent. I can't write it perfectly well, but that blue line is just tangent to the curve at that point, meaning it only touches the curve at that point, even though my graph may look like it doesn't. So we have a process for finding the slope of that tangent line. And remember, the way we're going to do it is we're going to find slopes of secant lines that using points that get closer and closer and closer. All right, so just to remind you, what I might do is I might start by finding the slope of the secant line using, let's see if we can do it this way. Whoops. Okay, so I might use this point right here. Let's start with that point. It's just another point on the curve, and there's going to be a secant line that goes through those 2 points. I can find the slope of that secant line simply by using the coordinates of the green point and the red point, right? So the green point has coordinates of 4, 0, and then of course the red point has coordinates of 3, minus 3. So the slope of that green secant line is going to be change in y coordinates, so minus 3 minus 0 over change in x coordinates, 3 minus 4. So this is minus 3 over minus 1, or 3. So the slope here is 3. Now that's not the slope of the line we're looking for. Remember, we're looking for the slope of the blue line. But that is an approximate slope. So the slope of the blue line is approximately 3. Now, we can get closer, we can get a better approximation by picking a point and doing the same thing again, but we want to pick the point that is closer to our red point. So maybe I pick a point down here, and I find the slope of that tangent line. That tangent line is going to be closer, that slope is going to be closer to the slope of the blue line. So let me create a little table of values, picking a few points that are closer and show you what's going to happen. Alright, so just a reminder, I'm going to pick points that get closer and closer to my original point and find the slope. So I pick the green one, then I pick the black one, then I pick another one in here somewhere that's even closer, and then I pick another one that's even closer, and I'm going to watch and see what the slopes of those secant lines do. Now I've done this, so let me see here. So here's the table. A couple things to notice about this table. First of all, the first point, the point 1, is always the point we're trying to find the slope of the curve at. It never changes, right? The point 2, that's the one we're changing. And how are we changing it? Well, it starts originally a distance away from the original point. But then it gets closer. And by closer, I mean the x values get closer and closer to the x value of our original point. So we start at 4, move to 3.5, 3.2, 3.1, 3.001. And those x values, we say that they are, we write it like this. We say the x's are approaching 3. They don't get to 3 actually, but they get closer and closer. Or another way of thinking about it is that the gap between our original point and the second point, the gap is what we call h. the gap is going to 0. So the gap between our 2 points, which we call h, goes to 0. And so, of course, every time we pick a new x value, we get new y values, right? So all of these guys are new y values that we're using. And then we use the points from this column, points from that column, to find the points from, or to find the slope of the secant line between those 2 points. And that's what we have here. We're using our basic slope formula, but I've gone y2 minus y1 over x2 minus x1 and found the slope for each of these points. Now notice, what is the slope doing? That's what we're trying to figure out. What does the slope approach? And if you look at that, we can see that the slope is approaching 2. And so that is the slope of the curve at the point.